Okay, now we're going to try to prove an identity, but we're going to use what they call compound identity, or a sum and a difference identity. Now this one's a little bit tricky. It's a little bit tricky. But so I'm looking at this thing and I see 2 times the sine of 5x times the cosine of 4x. The first time I looked at it, I thought, is this one of those 2 sine x cos x things where I can put sine a double? But these angles are different. So my head, it wasn't working. And then I looked at this 9x and I thought, ooh, 9x. 9x is really 5x plus 4x. So that's the thing I tried. I turned the sine of 9x into the sine of 5x plus 4x. And I wasn't even sure what was going to happen. But then I thought, okay, the sine of 2 angles added together. Well, it's equal to the sine of the first angle times the cosine of the second angle, plus the cosine of the first times the sine of the second. Or the way a teacher taught me before, just think sine, cos, cosine. And all you do is you go sine, it must be, if we use this structure, it must be sine 5x cos 4x plus cos 5x sine 4x. It's just sine, cos, cosine, and you keep this, when it's sine, you keep the sign the same. That's the trick, so I don't even need the formula thing. Okay, now I look at, well, what have we got here? Well, there we got a sine 5x and a cos 4x. Well, this is 2 sine 5x cos 4x. Well, sine 5x cos 4x, it's a like term. We got 2 bananas minus 1 banana. 2 sine 5x cos 4x minus 1 sine 5x 4x must just equal 1 sine 5x 4x. But if we minus this thing, we're minusing at this. This must turn into a minus now. Well, now we've got the difference. It's sine, cos, cosine. There's your 5x, 4x, 5x, 4x. Now we can use this formula to kind of work backwards. We've got the sine of an angle, the cos of an angle, minus the cos of that same angle times the sine. Hey, that's the sine of the 2 angles subtracted. Well, hey, that's what we're trying to get to, sine x. So 5x minus 4x, that's just the sine of, that means that's just the sine of x. And that's the right-hand side. So the right-hand side didn't even tell me much what to do in this side. Otherwise, somehow a bunch of stuff must cancel and simplify. But the key was this 9x is really 5x plus 4x, and then I expanded it using the formula. It's a lot easier just to remember sine, cos, cosine, and to keep the sign the same. Sine 5x cos 4x plus cos 5x sine 4x, keep the sign the same, and then I go, oh, 2 of these minus 1 of these, that's just 1 sine 5x 4x. And then minus the cos 4x 5x because I'm minusing out here. And then I just use the formula again. Okay, well, it takes practice to see these things and do it, but that's how you do this question, which was a little bit tricky. But hopefully that helped. I hope it did. Okay.